So hello everyone. So in today's class, we will see mainly the CMOS inverter configurations. So how the CMOS will be works like as a simple inverter, and also in what way we are designing the circuits CMOS different circuits by using CMOS transistors. So in the last class already we seen what is the MOS device operation and what is meant by how that MOS device will be implemented by using different materials. So that topics already were covered in the last sessions. So in today's session, we will see what is a CMOS logic circuits. That is the meaning of CMOS overview, and the CMOS inverter, and also the CMOS combinational logic circuits and the transistor sizing. So today we have to cover these topics. So basically, we know that CMOS is nothing but it is a simple complementary metal oxide semiconductor. So this will focus us on the implementation of digital logic circuits. So whatever we have to implement the digital application in terms of the electronics mode. So where that part we have to use mainly we have to implement those logic circuits by using the CMOS technology only, complementary metal oxide semiconductor technology. So wherever you see in laptop or desktop computers or some electronic devices, some modems and laptops and some any more electronic devices in mobile phones. So wherever we see in processor or microcontrollers or ICs, so those are implemented. Mainly those ICs are designed with by using CMOS technology. So in today's CMOS technology, so it is best suited for realizing digital systems. So whatever we are using some of the digital systems, those are nothing but counters and counting machines. Otherwise, in so many in realistic life, in case of in case of railway or army or navy. So when we see this type of departments, so where mainly we have to use most of the digital circuits or digital systems. So those digital circuits or digital systems manufactured or realized with CMOS technology. So why we are going for CMOS is so it has so many popular advantages. Based on those popularity, we have to simply design different type of circuits by using CMOS technology. So the CMOS technology, the main reason is so it has the CMOS technologies. It has the small size. So wherever we are configuring or we are placing, we are arranging all the materials within IC. So by using the CMOS technology, that will the overall circuit design and the circuit operation, the size will be decreases by using the CMOS technology. So that is the first reason is small size, and the second one is so it is easy of fabrication. So already we've seen different fabrication steps in case of NMOS and the CMOS and the PMOS fabrication. So whenever we are using the CMOS technology, the fabrication process also very simple and easy when compared with the NMOS and the PMOS devices, and it is used for low power operations. So whenever we arrange or we have to design these circuits in terms of the low power configuration, so that will be consume very low power. So whenever these devices operated with help of the battery, so that must and should operate in terms of the low power. So that is possible only whenever we can whenever we consider that ICs are devices that should be operated under low power configuration that is possible only with CMOS technology. And the second one is next advantage or popularity of CMOS technology is set relatively simply manufacturing process, and next one is high impedance, so that will be allows it to be used as a charge storage device. So wherever we have to design that any type of digital circuit, so it is simply at least that device is capable to store one bit of information. So simply it is simply when we are use a simple capacitor with a digital uh, with a digital techniques, so that will be used as a charge storage device. So that is possible with the CMOS technology. So considering the above features, so it have contributed to high levels of integration and correspondingly sophisticated circuit designs. So by considering the above popularity terms or the above popularity reasons, so it will be considered or this CMOS technology will takes place in high levels of integration. And also, so whenever we are following these CMOS technology, so that will be sophisticated the all the reliable designs. So that is advantages and the importance of the CMOS technology. So again, we have to see a simple CMOS device. So here we have uh, some configuration, CMOS configuration, that in that will be this design will be implemented by using the NVEL process. So within the P substrate, so we have to by combining N diffusion with the P substrate, so it will be acts like as a N MOSFET. So in the NVEL portion, so we have to diffuse P-type material, so it will be acts like as a PMOS device. So by combining the PMOS device and the NMOS device, so it will be acts like as a complementary metal oxide semiconductor. So already in the last semester, so DST also we discussed the CMOS configuration, a simple CMOS inverter, and how by using the CMOS technology, how we will implement different configurations or different digital operation circuits. So already we discussed. So whatever we have to discuss, so that same concept will be introduced here also, because of we have to design some of the stick diagrams and the layout diagrams in the coming next unit. So due to that, we have to know some basic knowledge about what is a CMOS circuit and how that CMOS circuit will be takes place in a digital circuit. So in what way we are designing by using the CMOS technology in terms of different digital logic circuit. So here by come the simple view or simple point of CMOS is, so whatever uh, it is the combination of both PMOS transistor and NMOS transistor. So that may be implemented by using different processes. That is nothing but NVEL process and PVEL process and twin tub process. So here the CMOS will be implemented in the NVEL process mix. So first of all, we have to take a P substrate. So within the some portion will be filled with some N-type material. So that will be acts like as a NVEL. So within the P substrate, we have to diffuse N-type materials diffused with N-type material. And within the NVEL portion, we have to diffuse P-type material. So that will be works like as a PMOS and the NMOS transistors. PMOS and NMOS transistors. So here, uh, whatever the diffuse material, so that apart above that diffuse material, so we have to make a contact source and the drain. So in the same in NVL also, what is the diffusion material? So uh, we have to extend that connections in terms of source and drain terminal. So here in CMOS technology, this CMOS is referred to as a complementary metal oxide semiconductor, and it also sometimes known as a complementary symmetry and metal oxide semiconductor. So this complementary and symmetry refers to that complementary and symmetrical pairs of both N-type and P-type MOSFETs in its a single structure. In its a single structure. సో మనకి ఎప్పుడైతే ఒకటే సబ్స్ట్రేట్ లో సో ఈ మొత్తం పిమాస్ ట్రాన్సిస్టర్ కానీ ఎన్మాస్ ట్రాన్సిస్టర్ కానీ సో ఇవన్నీ కంబైన్ అయ్యి ఒక డిజైన్ లోనే మనకు కానీ అవైలబిలిటీ ఉంటే సో దాని యొక్క కాంప్లిమెంటరీ అండ్ సిమెట్రికల్ ప్రాపర్టీస్ బేస్ చేసుకొని సో వీ కెన్ కాల్ ఇట్ యాజ్ ఏ CMOS device. So the main advantages of this design is so it has a low static power consumption and noise immunity. So it doesn't introduce any noise distortions within making or implementing of different digital applications, and also it consumes low static power dissipation. So what is meant by static power dissipation is static power means so whatever the circuit should be in operating mode or working mode or in ideal mode. So whatever in case of the ideal mode also that will require some amount of power or some amount of energy. For example, we are for example a human being in ideal condition is different from working condition. So the for example consider some X person and the Y person. So X person is sitting ideal, but the Y person is that person is running. Sometime that will be that person is running mode. So whenever we compare those two persons, so here the X person is also uh, that person also have some of the energy calories to sit and ideally. Yeah, that Y person is also that may that person also may have some of the energy calories, but the way of consumption of the energy calories will be different from one X person to Y person. So that is meant by static power dissipation. So even though the circuit the device in ideal condition, so the device may require some minimum amount of energy or minimum amount of power to operate or to perform those circuit operations. So that type of whatever the amount of power required or the amount of energy required to operate or to on the device. So that term we can call it as a static power consumption. So the transistor of pairing in the same device. So it is always that combines series and that will be draws significant power only momentarily during switching between the on and off states. So whenever we have to combine these two configurations or the two devices within the same configuration, so that on whatever the power required for on state and off state will be considerably, so that will leads to some switching power will be consumed in terms of the very low power case that will consumes very low power. And the CMOS circuits uses a combination of P channel and N channel metal oxide semiconductor field effect transistor to implement the logic gates. So this is the CMOS inverter. So simply where we studied or discussed under CMOS technology. So that will be detailed explained in a simple CMOS inverter. So after that we have to, so that is helpful for to understand so many CMOS logic circuits or logic gate circuits in the following sections. following sections. So it is a whatever we have a simple CMOS inverter we seeing. So in this diagram, so we are observing it is the combination of both PMOS transistor and NMOS transistor. So here whatever we are seeing the circuit. So it is both the combination of PMOS transistor and NMOS transistor. So here, whatever the bubble symbol indicates, it is the PMOS transistor, and without bubble, that will be symbol of NMOS transistor, and those two transistors will be combined. Applied to common input will be applied to the both the inputs, both the devices or both the circuits. Clear. So here we have consists of load resistor. So in case the circuit will be explained in two more configurations or two cases. Those are nothing but so case one. So in what is the input we are applying? What type of input will be applying for both the devices? So based on that, we have to clarify the operation of that circuit. So here the CMOS inverter. So this inverter circuit, so that consists of two complementary MOSFETs, that is the PMOS and NMOS. So here the input I serves as the gate voltage for both the transistor. So here whatever the input we are seeing, so that will be that input voltage will be applied common for both the gate terminals of both the transistors. Either it may be P-type transistor or N-type transistor. So in case one, for example, consider in case one, so we'll see the truth table of the circuit. So this is the CMOS inverter truth table. So in case one, we have to apply the inputs are applied to 0 and VDD voltage. So that is equivalent. The 0 is will be equivalent to logic 0 and the VDD is equal to logic 1. Logic 1. So here we have to apply these type of voltages at the input of at the place of high. So whenever the NMOS transistor has an input from VSS or ground in most cases, and the PMOS transistor has an input from VDD. So the terminal O serves as the output for both PMOS and NMOS. So here, whenever we give a high voltage is given at I, so the NMOS is turned on, while the PMOS is switched off. The output is pulled down to VSS. So similarly, when a low voltage is applied, the NMOS is switched off, while the PMOS is switched on. The output in this case becomes VDD, or the output is pulled up to. So first of all, we have to consider the input is 0. So at the place of I am applying the 0. So whenever I am applying the 0, so that will be applied to both P-type transistor and N-type transistor. So 0 means in case of the P-type transistor, so that 0 will be the gate voltage VGS is greater than V threshold voltage. So in case of the P-type transistor, so in for that case, so whenever the VGS crosses the V threshold voltage, so then the channel will be formed from the source to drain terminals. So whenever the channel forms, so internally the VDS voltage varies. So whenever the VDS voltage varies, the channel will be the current will start from one direction, that is from source to drain in p-type channel, in the p-type channel. So due to that reason, so that will be acts like as a closed switch at that case. So whenever it will be in on condition, so whenever the p-type transistor will be on, so that the vdd will flows through p-type transistor to output. So why it will be going to output means, so in the same position at the same instant of time, so we have also check what is the condition of NMOS transistor is. So the low input voltage 0, so that is similar equal to VGS is less than or equal to 0, less than or equal to 0. So that means whenever we have to apply the 0 for the NMOS transistor, so that doesn't create any channel from one terminal to another terminal. That means from source to drain. So whenever it doesn't create the channel, so at the time it doesn't induce or introduce the VDS voltage from one terminal to another, from one terminal to another terminal. So due to that reason, so there will be no current flowing from one point to another point in the NMOS transistor. So due to that reason, so it will be acts like as a open switch. So it will be the NMOS transistor will be acts like as a open switch. So in the case 1, whenever the input is 0, the PMOS is in on condition and NMOS is in off condition. So due to the off condition of the NMOS transistor, so the circuit will break at output O to VSS, So it will be that NMOS transistor will be in open switch. So because of that reason, so the VDD will be flows to the output. VDD voltage will flows to the output. So at the time whenever the input is 0, the output will be high. So because VDD is similar equal to logic high. VDD is equal to logic high. So first case is if the input is 0, output is high. Next, second case is, so that is one of the basic implementation or proof for a simple inverter. So in the case 2, whenever we have to apply the logic 1 to the PMOS transistor and the NMOS transistor. So for that case, so whenever we have to apply the logic 1 is nothing but it is equal to VDD voltage. So for the whenever we have to apply with the VDD to both the transistors, so at the time, so for PMOS transistor, so that is equal to VGS is less than or equal to 0. VGS is less than or equal to 0. So for VGS is less than or equal to 0, so in PMOS transistor, so that should be in, so that doesn't touches with the threshold voltage. So that the channel will not formed within the device. So from source to drain, and also whatever the device does not introduce VDS voltage. So irrespective of the VDS and irrespective of the channel, so that that doesn't not in a operate condition. That means the current does not flow through that device. So due to that reason, it will the PMOS transistor will be acts like as a open switch. So the same logic high voltage, the VDD voltage is applied to the NMOS transistor. So it is equivalent to VGS is greater than or equal to VD. So VT. So whenever that will be threshold voltage crosses, in NMOS transistor. So that will be the device will be creates a channel within the device from source to drain terminal, from the source to drain terminal. So whenever it creates the channel, so it induces some VDS voltage in between the source to drain voltage. So whenever it induces some VDS voltage, so due to that reason, so the current will flow from drain to source terminals, from the drain to source terminals. So based on this reason, so it will be acts like as a switch, on switch. That means in simple and clear cut point. So we have to say whenever the input is in high condition, so at the time the PMOS device will be off and the NMOS device will be on. So PMOS device off means, so it will be open circuited from the VDD to output. So from output to VSS, so that will be the path will be created from O to VSS. That means at the time the output is equal to VSS voltage. So output VSS means so the VSS is nothing but ground. Ground is equal to 0 volt. So whenever we are applying the input as a high voltage, logic high or VDD, so that similarly that is equal to the output is equal to low. The output is equal to, that means so it satisfies a simple inverter operation. So that's why you can call it as a CMOS inverter. So because of when we are applying input is 0, at the time the output is high, and the input is high at the time the output is low. So this is a basic inverter operation, and that operation should be implemented by CMOS. So CMOS nothing but it is the combination of PMOS and NMOS. So that's why you can call it as a CMOS inverter. CMOS inverter. So this is the basic operation or basic circuit design to implement any type of combinational circuit. To implement any type of combinational circuit. So that should be that same thing will be explained in terms of some resistor and resistors. That should be in case of whenever the VDD is Vin is high, so that the resistor P resistor will be open and the R resistor will be acts as a closed switch. So for PMOS operate, so there should be VGS is greater than or equal to VTP. So where VTP is the its threshold voltage, when high voltage VDD is applied, the VGS get to source voltage for the PMOS transistor becomes 0. So that is equal to VGS minus VS is equal to VDD minus VDD. So that is equal to 0 volts. So VSG does not satisfy the above condition. So therefore the PMOS does not operate, and it is assumed that it behaves like an open circuit. So because of it will be having a high impedance. So however VGS for NMOS is higher than the V threshold voltage, satisfying for the high condition. So here whenever we have to observe the input is high. సో హైలో ఉన్నప్పుడు మన PMOS అనేది ఆఫ్ లో ఉంటుంది, NMOS అనేది ఆన్ లో ఉంటుంది, అవుట్పుట్ అనేది లో వస్తుంది. సో that clearly explained in this session, in this PPT. However, VGS for the NMOS is higher than the VTN, so that's satisfying the condition for its operation, that VCS is greater than or equal to VTN. So hence the NMOS conducts by pulling down the output to VSS. So at the time, whenever the NMOS transistor in on condition, so at the time simply that the whatever previous it will be have that logic that should be exactly that should be pulled down to the ground. So that's why you can call it as the upper PMOS transistor is a pull-up transistor, and NMOS transistor is a pull-down transistor. So on the same lines, the inverter operation can be explained for a low input voltage. So in this manner, the not realized is a CMOS inverter. So whatever the gate, so that should be practically implemented. So that should be used as a any type of CMOS configuration or CMOS technology. So whatever you studied different circuits in switching theory and logic design or digital system design. So that should be implemented in coming to the VLSI technology. So that should be practically implemented by the CMOS configuration. Mainly that should be implemented by the CMOS configuration. So that is the main advantage or the basic operation of CMOS technology. CMOS technology. So the next here the CMOS inverters. So we have to remember these points. Points to be we have to note that simple. So a high voltage corresponding to that is 1, and the low voltage corresponding to logic low, that is 0. So the higher voltage the higher voltage is usually taken as or the source voltage, and the low input is usually equal to 0 volts. So it means high means, so that is simply related to the one logic 1, and low voltage means, so that will simply related or corresponding to logic low, that is 0. So the same thing will be explained in the this operation. So whenever we have the input 0 volts, 0 voltage, so that is that should be equal to 0 level, 0 logic level, and the input is VDD, so that should be equal to logic level. So the output for 0 case, so we get the output VDD voltage, so that is equal to logic 1, and the logic input is high. So at the time the output will be 0, we get the 0 volts, that is similarly equal to VSS voltage. So at the time we get logic output, logic 0. So for by using different circuits, by using different whatever we discussed, CMOS technology up to now. So that same information or that same operation will be used for to implement or to design different type of combinational logic circuits. Logic circuits. So that combinational logic circuits that should be implemented in so many applications of electronic industries, so wherever we have the electronic chip, in that we must should place a CMOS circuit. We should place a CMOS circuit. So that is about CMOS configuration, and the remaining concepts, that is what is meant by pull down and what is meant by pull up network, and what is meant by that combinational logic circuits, in what way we are designing those circuits. So we'll see in the next class. So detailedly we'll see that will be implemented, that should be implemented in different logic functionalities. So that should be, we'll see in the next class. So that is about the basic overview of the CMOS configuration, CMOS circuits.